Rebecca Lozano, and this is a video demonstration for a class. This is for Professor DeNova's Summer 2021 Physics 1025 online lecture. In this video, I'm going to demonstrate the law of conservation of angular momentum, which is described in our textbook in Chapter 8. And the classic example that you might think of when you are trying to visualize angular momentum is a figure skater on ice who can spin in place both slowly or very rapidly, and they fluctuate between the two pretty frequently in their routines by extending their arms and their legs and pulling them in towards their bodies. So before I do the demonstration, let's define some of these terms that I'm going to use first. So the law of conservation of angular momentum states that when no external torque acts on an object or a system of objects, no change of angular momentum can occur. In other words, this means that any momentum of a system is constant unless acted upon by net external torque. Also, the rotational inertia is the property of an object to resist any change in its state of rotation. Finally, angular momentum is the product of a body's rotational inertia and rotational velocity about a particular axis. So, without further ado, here we go. Hopefully I don't crash into anything. So, let's see how I spin. Ooh! That's a big change. So, as you can see, by moving the weights from the arm extended position to bringing them into the body, I can change the rotational inertia of my body. When the weights are held out, a fair amount of mass is distributed much farther from the axis of rotation. When I bring the weights into my body, my rotational inertia is decreased. That means when I decrease my rotation, my rotational inertia is decreased, my rotational speed can increase. Hope that demonstration was to your liking. Thanks again.